Okay, good morning everyone once again. Now this tutorial will be a continuation of your trigonometry. So in the previous tutorial, now I hope you have watched it. In the previous tutorial we discussed about the basics that we need or require to solve questions in your trigonometry. Okay, so now whatever basics we learned in the previous tutorial, we'll be applying those and we'll be solving a few section A questions that we'll be getting in your ICSE. Okay, so let's take you one example. Okay, so the first type of question, let's say it says prove that or show that. It says, let's say cosec theta plus cot theta is equals to 1 plus cos theta by sine theta. Supposing if we have something like this. Now as per the basic, we said that anything that we have in the question, we'll try and convert it into sine and cos. If it's not in sine and cos, we'll have to convert it. If we already have something in sine and cos, we leave it as it is, but like this one is not in sine and cos, we convert. And we gave you the formula also that whenever you have something in cos theta, so we had given you cosec theta was 1 by sine theta, sec theta was 1 by cos theta, tan theta was sine by cos, cot was cos by sine. And if we have a square over here, there also we'll have to put a square. If I have a square, I'll have to put a square here also. If it's a square, I'll have to put squares here also accordingly. Is that okay? So that is what we'll apply over here. So cosec theta we know is 1 by sine theta plus cot theta is cos theta by sine theta. That is equals to this. I write it as it is because already in sine and cos. Now over here we see fractions and then we see an addition. So we'll have to find the LCM, and LCM is the same thing. We just write it once. And then we copy this numerator as it is. So once you get a little more confident, you can skip this particular step. So we have the 1 as it is, and the sine gets cancelled, nothing left. We put a 1 plus the top one comes as it is, cos theta, then sine gets cancelled, nothing is left. We put a 1. So 1 plus cos theta divided by sine theta. So 1 into 1 gives me a 1. 1 into cos theta gives me a cos theta divided by sine theta is equals to 1 plus cos theta divided by sine theta. So if you just look, the left is already equal to the right, so we have already proved it. So this is a section A type of sum. So it's quite simple. All we have to do is we have to do the necessary conversions and then find the LCM. That's it. So let's take another example. Let's take one more example. So let's say if I have another question, let's say tan A plus cot A is equals to 1 by cos A sine A is what they have asked us to prove. Again, these two are not in sine and cos. Please convert. Tan is equals to sine A by cos A. Cot A is equal to cos A by sine A. And then this is already in sine and cos. No need to do anything. I write it as it is. Then now we need to find the LCM because fraction, addition. So I go ahead and find the LCM. They're different, so I simply just multiply the two of them. So when I multiply, what will happen? Again, LCM means they will come as it is, numerator, and then cos gets cancelled, left over is sine A. I write sine A. So how did I get this LCM part? A little more details I've already explained in the previous tutorial, but still over here also we are just following the same thing, but we're just skipping a few, not exactly skipping a few steps, but you're just going a little faster as compared to the previous tutorial. So if you think you get a little confused, you can watch the previous tutorial also. Okay, plus, and the numerator comes as it is, cos A, and the sine A gets cancelled, left over is cos A. We write the cos A, and this side we have 1 by cos A sine A. So then when I multiply, and I told you whenever we are multiplying in trigonometry, it's only the terms that will get multiplied and not the angles. So it's only sine, and sine gets multiplied, so we get a sine square and the A remains A, plus cos into cos becomes a cos square and A becomes an A, and down we have cos A sine A, and that is equals to 1 by cos A sine A. Okay, but now we just have to remember one more important thing. I think that I just forgot to inform you, but just remember that we have one more important thing to remember. Apart from these conversions and apart from finding the LCM, we still have one more important thing that you have to remember, and that important thing is this one. Okay, so there is one extra formula that you need to remember, and that formula is sine square theta. It could be an A also plus cos square theta. So if I have both sine and cos, if both of them are square, Condition is both have to be a square. You cannot have sine theta plus cos theta. You cannot have sine cubed and cos cubed. You need to have both square, and in between you need to have a plus. If I have this, then the answer for this is always equals to 1. So I get the same thing over here. So in the numerator, I see sine squared a plus cos squared a. Instead of theta, I have an a, but both have square, and there is a plus in between. So I can replace this entire thing and I can write it 1. So I can replace this and I can write it a 1. That is 1 by cos a sine a, and this is also equal to 1 by cos a sine a, and that's how it's proved. Okay, so you please remember this, an extra information called sine square theta plus cos square theta, because if I'm not aware of this, then I'll be stuck over here, and then the left right now does not look equal to the right. But if I know this, if I'm aware of this, then I can just replace that entire sine square plus cos square theta, and I can replace it by 1. So that is what we have done over here. Okay, but add on to this one, at times you may just have to manipulate this also. You just have to manipulate means sometimes I may have to take the cos squared that side. If I take it that side, so I know that sine square theta is 1 minus cos square theta. So the same formula, we can rewrite it this way also. So sometimes I may have sine square theta, I may have to write it as 1 minus cos square theta, or sometimes I may have 1 minus cos square theta, I may have to write it as sine square theta. That depends upon the question. Okay, and so you have this one, and from here I got this also. I can get one more extra thing. So instead of taking the cos square that side, I can take the sine square also that side. So sometimes I can write cos square theta is 1 minus sine square theta. So from here, in the first case, I took the cos square that side and I got this. In the second case, instead of taking the cos square, I took the sine square that side, so we can get that. So at times we know that we may have to replace sine squared by this, or we may have to replace this as sine square, or we may have cos squared theta. I may have to rewrite it as 1 minus sine squared theta, or sometimes we may get 1 minus sine squared theta. We may have to write it as cos squared theta. So you just have to remember the small extra thing also. Okay, so let's try a few more examples. Maybe we may come across certain questions where we may have to apply these two new things also. Okay, so let's try and check a few more. So let's say if I have to do another one, let's say the question says tan square theta plus 1 minus 1 by cos square theta, prove it equals to 0. So then what do? This is not in sine and cos. I write it sine square theta by cos square theta plus 1 as it is minus 1. This is already in cos. I leave it as it is, equals to 0. Now, usually what I tell the students, if there is nothing in the denominator, just try and put a 1 if you think you will get confused. In case you think you can manage without putting a 1, you don't have to. It's not necessary. But now everything is a fraction and it's all addition, subtraction of fractions. Find the LCM. So cos squared, the same thing. We just write it once. And then we have a 1, we can write it. Okay, I said these few small steps can be skipped once you start feeling a little more confident. Okay, so then I copy the numerator as it is, sine square theta, then cos squared gets cancelled, left over is a 1, I put a 1. Then we have a plus, I copy the 1 as it is, and then 1 and 1 gets cancelled, I put the cos square theta. Then minus, I copy the 1 as it is, then cos squared gets cancelled, I put a 1 equals to 0. So then 1 into sine squared gives me a sine square theta, plus 1 into cos squared gives me a cos square theta, minus 1 divided by 1 into cos squared theta gives me a cos squared theta is equal to 0. But now, just now we learned that sine square plus cos square gives me a 1. So I can replace the two of them. So the entire thing, I can take it out in its place. I can put a 1 minus 1 divided by cos square theta is equal to 0. And 1 minus 1, we already know it's a 0 by cos square theta is equal to 0. 0 divided by anything is 0. So we get 0 is equal to 0. That's how it's proved. Okay, so again, the same thing. If I'm not aware of this, I'll be stuck over here and I'll never get my left hand side equal to 0. But once I know this is equal to 1, we just replace it, and then that's how we get 1 minus 1 is 0. And we should know an add-on thing that 0 divided by anything is 0. Okay, so that's how we did this. Let's try another example. Let's talk about this one. So let's say there's another question which says sec squared a plus cosec squared a is equals to sec squared a cosec squared a. Okay. Now this is not in cos or sine. I converted. I said if it's a square, I know sec is 1 by cos, but if there's a square, I need to put a square over here also. Cosec is 1 by sine, but there is a square, I need to put 1 by sine square A. And then this sec square is again 1 by cos squared A, and then cosec square is again what? 1 by sine squared A. So now we see fractions, there is a plus, so I need to find the LCM. LCM is the multiplication of these two. So I copy the one as it is, cos squared out, left over is sine squared A. Plus I copy this as it is, sine squared out, I get cos squared A. And then this side, over here also we have fractions, but since there is no plus minus in between, there is a multiplication, no LCM. LCM is found only when I have addition or subtraction of fractions. So over here it's a multiplication. We simply multiply numerator into numerator, denominator into denominator, and we get this much. So then this side we get 1 into this gives me the same sine squared A, plus 1 into this gives me the same cos squared A, divided by these two multiplied, I get cos squared A, sine squared A, and this side I get 1 by cos squared A, sine squared A. But just now we have learned sine squared, any angle, plus the cos squared, the same angle. If I have both AA or both theta, we can replace it as 1, and then down I get cos squared A, sine squared A, and that is also equals to the same thing on the right hand side also. That's how we have proved. Okay, so it's quite simple. So these are all section A. It's not that I'm doing all easy sums. It's all, these are the types that come in your section A. So if you think that it looks simple, then I think you'll be able to solve questions in your section A. Okay, you don't have to worry much about it. So let's take you more examples. Okay, divided by sine A, cos A. So then what do I get? I get 1 plus cot A is cos A by sine A, plus sine A by cos A is equals to 1 plus sine A cos A divided by sine A cos A. So there is nothing means advisable. I put a 1 and I need to find the LCM, addition, subtraction. So what do I get? We get 1 into sine A into cos A. So I put the 1 and then 1 out. I have sine A cos A. Both of them will come. Then plus I put the cos A. Sine A gets cancelled. 1 into cos A, I get a cos A. Okay, because see, I need to put both 1 and cos A inside, but they are getting multiplied. So 1 into cos A, I wrote it as cos A only. So I put the sine A down. Then the cos A gets cancelled. So 1 into sine A is what goes inside, but 1 into sine A is already a sine A. Okay, and then this becomes 1 plus sine A cos A divided by sine A cos A. So when I multiply, 1 into this gives me the same sine A cos A. But now cos into cos gives me a cos squared A, plus sine into sine gives me a sine squared A divided by 1 into sine A. Sine into cos A is sine A cos A. And then this side I leave it as it is, divided by sine A cos A. And then these two, if I look carefully, what about these two? These two, we already know the answer is 1. So I can just replace it. I can write it sine A cos A plus 1 divided by sine A cos A, and that is equals to 1 plus sine A cos A divided by sine A cos A. So, and then if you look at the left and the right, it's already the same, so it's approved. So a majority of the question we are all getting cos squared A plus sine squared A. We just need to remember that, and if I remember that, we'll be able to solve it. So let's take another example. So let's say if I take this question, let's take a little different. Okay, so let's say I have cosec theta minus cot theta, and I see a square that is a whole square that is equals to 1 minus cos theta over 1 plus cos theta. This is what they have asked us to prove. So then what do? Forget about the square for the time being. You only focus on the ones that do not have a sine and a cos. So cosec does not have, so I write 1 by sine theta minus cot is cos theta by sine theta, and I write a square. And that is equals to 1 minus cos theta over 1 plus cos theta. So then I need to find the LCM. So when I find the LCM, we have what? Sine theta as it is. Okay, then 1, I'll write it over here, then sine theta, this, everything gets cancelled, I just put a 1. Minus the cos theta comes as it is, sine theta gets cancelled, nothing left, I put a 1. and I have a square, 1 minus cos theta over 1 plus cos theta. Okay, so now what do I have? We have 1 minus cos theta over sine theta square is equals to 1 minus cos theta over 1 plus cos theta. Now whenever you have something like this, okay, if you already know it, that's very good, okay, but in case you do not know it, then let's say for example, if I have a minus b divided by c whole square. Now if the numerator has a plus or a minus between them, okay, first thing is, before I do this, let's say if I have a by b square, then this new square is for the numerator also, square is for the denominator also. So then how do I write it? I write a squared by b squared. That's how we write. But if I have a numerator or a denominator where there is a minus or a plus in between, then what will happen? This numerator, I write it as it is. So when I write this square, just like I said, is for the upper one also, lower one. So this square is for the numerator also, denominator also. So we write a minus b square and c square. So the numerator, the square is for both the numerator and the denominator. So I have to take the entire thing as my numerator, put it inside a bracket, and the square will be for this also, square will be for this also. So the same thing over here. The square is for the numerator also, for the denominator also. So I write 1 minus cos theta square divided by, now the square is for the denominator also. Okay, and I write this. So sine theta whole square means, it means if I have sine theta square, it means it is sine theta into sine theta, and everyone knows sine into sine gives me a sine square theta. So I can write the same thing as 1 minus cos theta square, and then I have a sine square theta is equals to 1 minus cos theta over 1 plus cos theta. Okay. And then the other important thing, just now we told you that, see, if I have like this one, a minus b, if I have square, I can apply the formula. So we can, normally what we do is we write it as a square plus b squared minus 2ab. But in trigonometry, we do not write in this form. So the other way of writing this is this way. Okay, just like x square, I can write it as x into x. 5 square, I can write it as 5 into 5. Similarly, if I have a minus b square, it means the same thing. I can write it twice. Just like if I have x and a square, I write this 2 times. I have 5 square, I have 5 and 5. I have the same thing, square means I write the same thing twice. Okay, so most of the other chapters, we usually express this in this form. But in trigonometry now, we will no longer be expressing this in this form. We will be expressing the same thing in this form. And why are we doing that? We'll let you know in a while. Okay, so if I see 1 minus cos theta square, so it looks something like this. So I'm not going to apply any formula. The way I'll write it is, I'll just write 1 minus cos theta twice. 1 minus cos theta. Okay, and then we'll tell you why are we doing that. So I have 1 minus cos theta whole square. So though I can write it and express it in the form of a minus b whole square, but I said in order to go ahead and make sure that I solve my question, I will not be applying the formula. We will be rewriting it in this way. So I'll write 1 minus cos theta twice, the same thing twice. Okay, because just now I explained you the same thing can be written this way. So I have 1 minus cos theta, I'll write it this way. And then denominator sine square theta, just now we went ahead and then we talked about this one. Sine square theta plus cos square theta is 1. But the same formula, sometimes as per the question, as per our requirement, we may have to manipulate the formula, I said. And sometimes we may have to write sine square is 1 minus cos square theta, or sometimes we may have to write cos square theta is 1 minus sine square. So what do we have in the question? We have sine square theta. So sine square theta has to be written as 1 minus cos square theta. So we write it as 1 minus cos square theta, and that is equal to 1 minus cos theta by 1 plus cos theta. Okay, and then now once I get this, now if you look at the denominator, it looks like if I have a squared minus b squared, then how do I express it? I have a plus b, a minus b. That's the formula. So if I have, let's say, x square minus, let's say, 5 square, I can write it as what? X plus 5, x minus 5. Similarly, now if I see something like 1 minus cos square theta, so I can imagine it to be like a 1 square, and then this looks like it is like a square minus b square. So then how do I write it? The formula is a plus b, a minus b. So I can write it as a is 1 plus b is cos theta, and I can write it as 1 minus cos theta. So I can write this as this. Okay, so I can imagine the 1 to be as a 1 square. It's already cos squared, so it looks like a squared minus b squared, a plus b, a minus b. So I can write the numerator as it is, and down we will write it as a plus b, a minus b, and then this as it is. And then if you look carefully, this 1 minus cos theta and 1 minus cos theta will get cancelled. The reason why we're not applying the formula and why we're expressing this is because we want the cancellation to take place. Because if I apply the formula, the cancellation will not take place. That's the reason why we have to go ahead and express it in that form. So left over is 1 minus cos theta, down is 1 plus cos theta. Right hand side also we have the same thing. So now if you look carefully, the left and the right, they are exactly the same, and that's how it's proved. So this was a little bit trickier somewhere. We had to know a few extra things, but I've tried my level best to go ahead and explain you what are the extra things. In case you have any trouble, any confusion, I keep on saying, just let me know where exactly you have any confusion, and maybe that particular topic or that particular portion I may make some other tutorial, or I may do something extra, or maybe make it a little simpler. So you just let me know, and then I'll try my level best to do that if there is any confusion. Okay, you can always feel free to let me know. So that's it for the time being. So we've given you a lot variety of section 8 of sums. So if you have any confusion, please do let me know. Okay, so that's it for the time being then. Thank you very much. Okay.